Hello. All right, welcome back. So today in this video, I'm going to be going through the assignment that is called More Solving of Linear Equations. And one thing I do want to let you know is when I went through and did these problems before making this video, I noticed that a lot of these problems have very similar processes that they go through. So I'm going to explain some of them in maybe more detail than others, okay? And please remember, you can always just check the key, but if you needed to hear a little bit more of an explanation about why you do things in a specific order or what your options are, that's what this video is for. All right, so to take it away, let's take a look at problem number 1. Now, some people may have done what is called distribution and multiplied everything by 5 on the left-hand side. I would like to let you know that if you want, you can choose to divide by 5 on both sides, okay? Because it's 5 times something, so you can divide that 5 out. So then you'll have x plus 2 equal to 25 divided by 5 is 5. And then because we are adding 2 on the left side, we will subtract 2, and now we will have x equal to 3. And please remember that solving means you're trying to isolate, and you know, when you feel isolated, that's when you're alone, the variable. You're trying to get the variable alone. So that's why we're moving all the numbers and leaving the x all by itself. So in problem number 2, I'm going to do something very similar. And I'm going to be left with 2x plus 10 equals 20 because I'm dividing both sides by 2. And then I'm going to notice that 2, 10, and 20 are all even. So you could go the route of dividing everything by 2. You can't do that all the time, okay? That's not like a step you can take every single time. It works in this problem. In general, the better move is going to be to subtract the 10 over to get the x, well in this case the 2x, closer to being by itself, and then dividing by the 2 that's out front. All right? So x equals 5. All right, pretty much problem number 1 and problem number 3 are the same. So the answer in problem number 3 is that x equals 6, okay? And that's because you can divide both sides by 3. You get 2x minus 5 equals 7. You get 2x equals 12 because you add the 5 over, and you divide both sides by 2. All right, number 4 is the first one where I'd say I wouldn't recommend doing this problem any other way than, in terms of starting, distribution. Okay, you're going to distribute the 4 and the 7 to their respective terms. And then in this moment, it's kind of up to you what you want to do. Here's my little tip. When I'm moving the variables, so see the 20 and the 14, I'm always going to move the smaller one so that my variable stays positive. So I'm going to choose to subtract 14x. I could have moved the 20 to the right, but then I would have had a negative amount of x's. Instead, I will have a positive amount. So then, no matter what, the numbers are going to be what they are, so I have to move the 12 to the other side, because if I'm moving all the variables over here to the left, I have to move the numbers to the right, so it's going to be 33. And then I'm going to divide both sides by 6 because I'm multiplying by 6. So then x is going to equal 11 over 2. Okay, now if you're using your calculator, it may have given you a decimal. I'm not really a big fan of using my calculator unless I absolutely have to, and I can tell that both of these numbers are divisible by 3, so I'm just going to use my noggin in this situation. I do want to point out here in this moment that very often students will say things like, is this answer right? Whenever they get a fraction or like something that doesn't seem like a quote-unquote nice number. Guys, all numbers are nice, okay? They're just numbers. They're not looking to hurt you. This isn't like a 6 is afraid of 7 because 7, 8, 9 situation. They're just numbers. So we're going to get some answers that are whole numbers, which might feel nice. And we're going to get some answers that are different than whole numbers. And that's okay. Just like let them be. It's all good. Okay, so number 5, very similar to 4 in the sense that there's some distribution happening. So we're going to get 12x plus, oh, I'm so sorry. We're going to get 12 plus 3x and 50 plus 5x. And then, if you're living right, you should have gotten x equals negative 19. Okay, I'm not going to show you all the work for that one. Your choice how you get to x equals negative 19, but you've got to distribute first. Okay, and then in number 6, same situation. 6x minus 8 equals 4x plus 3. And then move the variables to one side, move the numbers to the other side, and once again, weirdly, not weird, it's fine, you get 11 over 2. Okay, all right, moving along. Now, there are moments where we read a problem and we read it too quickly, okay? And I think that that could happen in number 7 if you're not being careful. So, just looking left to right, just like you read. 3 is going to be distributed, and then we have an equal sign. So that's it. So we get 3x plus 6 equals. Okay, and then this is the part where I get a little worried. I'm going to highlight this number. Negative 2 is attached to the parentheses. So negative 5 has no, like, it's not part of the party yet, if you will, okay? Negative 5's kind of on the outside looking in right now going, when can I join the math party? We have to distribute the negative 2 first. And then we can combine it with some other things, okay? So just be careful, all right? Just because something is listed first in a line of work or sooner from left to right doesn't mean you get to use it right away. Okay, and then again, kind of up to you on if you want to like combine these numbers on the right side. I think that's kind of a good idea because you make sure you've combined like terms before you move things to the left and to the right. So at this point, we should add the 2x. We should subtract the 6. So that's gone, that's gone. So I have 5x's equal to negative 5. So x is equal to negative 1 after I divide by 5. All right, we've got 3 more problems. Okay, so I'm actually going to go just like around the horn. I'm going to do 9, I'm going to do 10, and I'm going to save 8 for last. Okay, so we've got 2x minus 6 equals x. Oh, okay, we've got to talk about this really quickly. In math, there are invisible symbols sometimes. Ones all over the place. Like right now, there's technically a 1 in front of this parentheses. Well, 1 times anything is just whatever that thing is. So 1 times x minus 1 is just x minus 1. So we don't need the parentheses. We can just drop them because it's itself. So then we're going to add 7. So we get 2x minus 6 equals x plus 6. So I'm going to subtract the x over. I'm going to add 6. So I get that x equals 12. All right. And then 10, there's this negative. That's technically, see, this is another invisible number. That's a negative 1. Not just a floating negative. It's just a 1. So we distribute that. We get negative 1x minus 7, negative 6x plus 8. And then however you want to move variables to one side, numbers to the other side, you should ultimately get that x equals 3. All right, so 8 I saved for last for a variety of reasons. But I'm going to start with the fact that as we distribute, everything looks peachy keen on the left-hand side. And then on the right-hand side, you're probably like, oh, a half? What am I supposed to do with the half? Well, this problem's not too terrible. Look at these guys. These are even numbers. So just take half of those values, right? 1 half times 4 would be 2. So 2 x's. Half of 12 is 6. So this is negative 6. Now, let's say you're like just kind of, okay, you got over that. You did that. You sorted that out. And you're just kind of working through the process I said, which is getting a variable by itself, okay? So you add 6 to both sides. So now you have 2x equals 2x. And you move all the variables to one side, so you subtract. And so you get 0 equals 0. You may go, I don't know what to do in that situation. And that's fair. It's kind of weird. You didn't get variable equals number, you got number equals number. And not only that, the number you got is 0. So you're like, your brain's probably like, what is going on? Big question marks, like, whoa. Okay, let me just ask you this. Take a moment. is this statement true? Does 0 equal 0? Hopefully you said, yeah, 0 is 0. 0 equals 0. Okay, is it true all the time? Like if I told you I had no cake, would that mean the same thing all the time? Yeah, I mean I'd have no cake. Bummer. So here's what happens when you have a number equal to a number and the statement is true. So this is true. That's a yes. So I'm going to change that from a question mark to it. This is true. All right, if it's true all the time, then we answer differently than all the other problems, okay? The answer to number 8, I'm actually going to write up here. We say that this answer has infinitely many solutions. Every other problem that we did, see, here's the thing. In algebra, all of these problems are really questions. They are, when does the stuff on the left side equal the stuff on the right side? And in every other problem, there's only one scenario in which that works. X equals 5. It's only time when the left side equals the right side, when the left side equals the right side. In number 5, the only time that the left side equals the right side is when X equals -19. However, in number 8, you all could pick a different number right now, substitute it into the left and the right, and it will work. Every number works. That's what's different about it. All right. Thanks for listening. I hope you didn't mind me going on a couple of rants maybe about how you can approach your problem solving or my whole thing about the 0 and all that stuff and the infinitely many solutions. I hope you have a really great day. Thanks for sticking with me, and we'll do some more math real soon. All right. Have a good one.